let's start the lesson next week. So that will be on the 19th. So November the 19th will be your test 3, and that covers 2.6, 2.7, 3.2 to 3.4. Okay, composition of function, inverse function, which I will cover today, and then polynomial. To discuss inverse function, let's recall what we know about function. A function is a correspondence from one set to another set, such that each element in the domain corresponds to only one element in the range. So every element in the domain corresponds to only one element in the range. In other words, it does not allow any element in the domain to go to two different elements in the range. No, that's not. Okay. Notation wise, then, because every element in the domain goes to only one element in the range, then we can use this notation: FA equals to what, FB equals to what, FC equals to what. Because the outcome, when A in the domain corresponds to only one element in the range, then you can use that functional notation. Now that's about the function. We go on further, a new definition for us. A function is called one-to-one function if each element in the range also corresponds to exactly one element in the domain. So in other words, every element here comes from only one element in the domain. Every element in the range comes from only one element in the domain. Okay, so you see that in the earlier mapping here, this function, this relation is a function, but it is not one-to-one. Why? It's not one-to-one because there's an element in the range, element 2, that actually comes from two elements in the domain. So this is not a one-to-one, even though it is a function. One-to-one function must look like something like this. Okay, so it will be one element here, one element there, one element here, one element there, like that. There's no branching at all. No branching no branching in the domain. Also no branching in the range. No branching in the range like this. No, it's not. Okay, no. Now, once we have that one-to-one function, then how do we recognize the graph of a one-to-one function? One-to-one function, well, as a function, it must satisfy horizontal, it has to satisfy vertical line test as a function. Now, as a one-to-one, it must satisfy horizontal line test. That is, every horizontal line will intersect the graph at most at one point. Now, let's see some example. For example, we have x squared function. Now, it is a function because every vertical line, it intersects the graph at most at one point. So x squared is a function of x. However, it is not one-to-one. Why? Because we can easily find a horizontal line that intersect the graph at two different points. Okay, so this is a function, but not one-to-one. So how about a function that is one-to-one, Thomas? Can you give us an example? Yeah, sure. Actually, any linear function is one-to-one. Every linear function is one-to-one. as long as the slope is not 0. So let's say I have this line here. Okay, now you see that every time you draw a vertical line, it will hit the graph at most at one point, right? So it is a function. On the top of that, when I draw a horizontal line, it will hit the graph at most at one point also. So it is one-to-one. Okay. So this is a one-to-one function. One-to-one function. The function 1 over x is also a one-to-one function. The graph of 1 over x is also a one-to-one function, because every time you draw a horizontal line, change the, every time you draw a horizontal line, okay, it hits the graph at most at one point. Okay, so we know that fx equals to 1 over x is a function. We know that. Now, the fact that it is one-to-one is something that we check using a horizontal line test. Okay, now, once we have a one-to-one function, then we can talk about an inverse function. Definition: let fx be a one-to-one function. So it is one-to-one and it is a function. Then there is a function, let's call that gx for now. Gx, also one-to-one. That undoes what fx does. So using mapping as illustration, suppose a function f send a to 1. Let's say f sends a to 1, fa equals to 1. Then gx will send that 1 back to a. G1 is equal to a. Okay, now this function gx, this gx is called the inverse function of fx. And denoted f inverse x. Okay. Now let's practice some notation first. For example, let fx equals to 2x minus 1. Now we know this function is one-to-one. Why? Because the slope is 2. It's a linear function with slope 2. Okay, notice that it satisfies horizontal line test and vertical line test. Now, Then let's see, for example, what is F3? F3 is 2 times 3 minus 1, that's 5. Okay, then if I want to send 5 back to 3, I use F inverse 5 equals to 3. What is the input such that the output is 5? F3 means what is the output if the input is 3, right? Okay, now F inverse 5 means what is the input if the output is 5. Okay, so you see that the 5 is the output for the function. Now that output is the input for the inverse. Okay, now let's say, suppose I ask find F inverse 10. F inverse 10 equals to what? Then the way we do it will be write that function 2x minus 1, set it equals to 10. If the output is 10, what is the input? Then you write that function equals to 10, and then you solve for x. So f inverse 10 is equals to 5.5. Okay, now from here we see some phenomena. From here we see some phenomena. And this phenomena is actually very important. The domain of the one-to-one function f, let's say this is our f, this is the domain. And this is the range. Now, what I said earlier, inverse function, f inverse, has the domain equals to the range of fx. And the range of inverse function is the domain of f. Let me write it explicitly. Domain of the function f is equal to the range of inverse function f inverse. And the range of the function will be the domain of the inverse function. Okay, so if you think about this, notation-wise, fx equals to y, where the x is the input, y is the output. Now, when you do f inverse, the output that you had earlier now becomes the input. Right? And that's why we have this kind of switch. The domain is equals of the function is equals to the range of the inverse. On the other hand, the domain of the inverse is the range of the function. Actually, furthermore, you will see the following phenomena, and we will see that very soon. Okay, you will see that the x-intercept of the function correlates, has something to do with the y-intercept of the inverse. Y-intercept of the function has something to do with the x-intercept of the inverse. Okay, and actually a lot more. You will see basically to do the inverse, to find the inverse, we swap x and y. That's what will happen. That's what will happen. Your x becomes your y becomes your x. Your domain for the function now becomes the range of the inverse. The range of the function now becomes the domain of the inverse. Okay, now then you will see eventually the procedure to find an inverse is the following. To find the inverse function of a one-to-one function is done in 4 steps. Now, in your test, when I ask you to find the inverse function, I need you to do it in this 4 steps, also in this 4 steps. Okay, the first step, given fx, your first step, change fx to y. Second, we swap x and y. Now, let's say I use this illustration here. So let's say, for example, our function is fx equals to 2x minus 1. That's an easy function, right? So step 1, y equals to 2x minus 1. Okay, I basically change that fx becomes y. Now, in my test, I require you to even to show me these steps, including your step 1, 2, 3, 4. So I require you to show me this. Okay, not just like this, the result, but show me what step are you in. Step 1, you change fx becomes y. Okay, then step 2, we swap the x and the y. X becomes y, y becomes x. Now, de-inversing is actually done in this step. De-inversing is done in step 2. Now, step 3, we will solve for y. So you isolate the y. X plus 1 equals to 2y. X plus 1 over 2 equals to y. Okay, and finally step 4, change y to f inverse x. So I will rewrite this y now becomes f inverse x equals to x plus 1 over. Okay, that's the procedure. That's the procedure. Now you will see the following from here. I just tried to confirm what we had. What I'm about to do is like to confirm this. Okay, at least you see that if we look back into our fx equals to 2x minus 1, what is the y-intercept? The y-intercept for fx equals to 2x minus 1 is 0, -1, right? Now you will see that that is actually the x-intercept of the inverse function. The x-intercept of the inverse function is -1, 0. Now, the x-intercept of the function, you set the y equals to 0 and you solve for x, right? So the x-intercept is 1/2, 0. That is actually the y-intercept of the inverse function. Okay, so you see the x-intercept here is the y-intercept there. The y-intercept here is the x-intercept there. Okay, now I said earlier that the inversing actually done in this step 2. Why? Basically, when you do inversing, the x becomes y becomes x. So the x-intercept becomes y-intercept, y-intercept becomes x-intercept. The domain becomes range, range becomes domain. Now, if we graph both of these functions on the same coordinate plane, if we graph both of these functions on the same coordinate plane, then you will see that this is, let's say this is 2x minus 1. Okay, now then x plus 1 over 2 will look like this. Will look like this. That is the reflection of the graph with respect to x equals to y axis. So this will be 2x minus 1. This is the inverse, x plus 1 over 2. And your x-intercept, original x-intercept becomes y-intercept. The y-intercept becomes x-intercept. Okay, you reflect the graph with respect to x equals to y line. So any point you get here is actually reflected there. Any point you have here, reflected there. Okay. Now let's do more. Let's do more. Following that procedure. Following that procedure. For example, find f inverse x for of fx equals to square root of x minus 4. Solution. Fx equals to square root of x minus 4 has domain. The domain here is x must be greater equals to 4. Is it right? Okay. Now then, on my first step, I change the fx becomes y. And then second, I swap the x becomes y becomes x. Now you will see then the requirement that x is at least 4 now becomes y is at least 4. Okay, oops, the last one should be 4, not x. And then I will solve for y. I square both sides and then add 4. I get y. Now you see my requirement that the x has to be greater than 4 now becomes y is greater than equals to 4, right? Now you also see that the range originally is y is at least 0. Now the x becomes at least 0. Why do we need that, Thomas? We need this because the function, the inverse function, has to be 1 to 1. Now, you know x squared plus 4 is not 1 to 1. X squared plus 4 is not a 1 to 1 function unless you do restriction. Unless you do restriction. So x squared plus 4. What I want to say is the following. Let's say this is our coordinate system. Now, square root of x minus 4 looks like this. Square root of x minus 4 looks like this. This is square root of x minus 4. Now, according to our theory earlier, that the inverse function must be the reflection of that with respect to this y equals to x line. So this x-intercept, which is 4, 0, will soon become 0, 4. Okay, and the graph's supposed to look like this. That's what the graph's supposed to look like. Now, notice that if you graph this in full, it's supposed to look like this, right? It's supposed to look like this. But you see that this function is not 1 to 1. It's not 1 to 1. Okay. While we know that if a function is 1 to 1, then the inverse has to be 1 to 1 also. Okay. Now we can only be aware with that 1 to 1-ness if we are aware with this restriction we originally have. Okay. This is x squared plus 4. X is greater or equals to 0. So when you find inverse function, one thing you need to pay attention is the 1 to 1-ness, and you can actually see that from the restriction on the domain and on the range. Okay, so earlier I kind of like write down the domain and the range, so such that I get the same thing later on with the domain becomes the range becomes the domain. Okay, now that's basically what we need to be aware of with inverse function. How to find inverse function, we do that 4 steps. Okay, now let's do some problem from our textbook. For example, I do number 30. Number 30. Find f inverse, the inverse function of fx equals to 1 minus x cubed. Solution. Step 1, I change the fx becomes y. Step 2, I swipe the x becomes y, y becomes x. And then step 3, I solve for y. Then I do cube root here. So step 4, I get f inverse x equals cube root of 1 minus x. That's for number 30. Now, how about number 32? Number 32, we have fx equals to 1 over 1 plus x, where x is at least 0. So step 1, solution. Step 1, y equals to 1 over 1 plus x, where the x is at least 0. Step 2, I swap the x becomes y. So this becomes y also, y at least 0. Now then I will solve for y. So x times 1 plus y equals to 1, where the y is at least 0. X plus xy equals to 1 for y at least 0. And xy equals to 1 minus x, y equals to 1 minus x over x. All of them for y at least 0. Therefore, the inverse function now becomes 1 minus x over x for the y at least 0. Now the thing is, y at least 0 refers to this guy, right? Okay. Now what will the x be if y at least 0? Then we need to go extra mile. What are the x's to have the output to be at least 0? So 1 minus x over x at least 0. Step 1, critical numbers. Long time no see, but you need to know this. 1 minus x over x equals to 0. Remember, when you solve for inequality, that's what you need to do. Critical numbers, right? So the critical numbers are 1 and 0, 2. Sine graph. 0 and 1, undefined at 0, 0 at 1, and the sine graph will be negative, positive, negative. And finally, you do the solution. So the x will be between 0 to 1. Right? Go back to that step 4. So step 4, inverse function of x is 1 minus x over x for x between 0, not including 0, up to 1, including 1. Okay. One more example. One more example. Let's say number 62. Number 62. Let fx equals to 8x minus 4 over 2x plus 6. I want you to find the inverse function. And later on, we will have follow-up question. Let me ask you to do this first. I give you how many minutes? Maybe 2 or 3 minutes. Okay, so you do step 1 and then step 2. Now, in your step 3, which is a bit longer, you will multiply by the LCD and then do factoring for the y. At one point, you will factor the y. Okay, let me make you think a bit for 3 minutes. So step 1, y equals to 8x minus 4 over 2x plus 6. Step 2, I swap the x and the y. So I get 8y minus 4 over 2y plus 6. Now step 3, I will isolate the y. I multiply both sides by the LCD. 2x 2xy plus 6x equals to 8y plus 4. Isolate the y, so 2xy minus 8y equals to negative 6x minus 4. Y equals to 2x minus 8. Y times 2x minus 8 equals to negative of 6x plus 4. I factor the negative out. So y is equal to negative of 6x plus 4 over 2x minus 8. You know what? I will reverse the order subtraction at the bottom so that I get rid of that negative. Okay, because negative of 2x minus 8 is the same to negative 2x plus 8, which is the same to 8 minus 2x. Okay, now then my step 4, my final step, inverse function of x is 6x plus 4 over 8 minus 2x. Okay, so I'm actually done with that question. Now the follow-up part that I want to do is the following. Let's put this fx and f inverse x next to each other. So fx is equal to, what's that? That's 8x minus 4. 8x minus 4 over 2x plus 6. Right? While inverse function is 6x plus 4 over 8 minus 2x. Now, the things that I would like you to pay attention. The first one is the domain. What is the domain of this function? The domain of this fx. That will be all real numbers except when 2x plus 6 equals to 0, right? 2x is negative 6, x equals to negative 3. So the domain is all real numbers except negative 3. That's the domain. Now, if you think about it, that domain in the function later on will become the range of the inverse function. All real numbers except negative 3. Actually, hold on. Something not really right. Do I copy anything wrong? Oh, that's correct. That's correct. Now, so I can actually ask you this question then. Can you find what is the range of the function? One way to answer the question of the range of a function is look at the inverse. So what we can do is we look at the domain of the inverse function. What is the domain here? The domain is all real numbers except something. 8 minus 2x cannot be 0, right? So if it is 0, what will x be? X will be 4. So the domain of the inverse function is all real number except 4. Now that will tell us the range of the original function. It is all real number except 4. So you see, I can find the range of this function without actually graphing it. How? I actually do the range, do the inverse first. I find the inverse and look at the domain of that inverse. The domain of the inverse is the range of the original function. Now, this technique does not work all the time. Okay, this technique does not work all the time, but it definitely works when the function is one-to-one, and therefore we can find the inverse function. Okay, now if you happen to take pre-calculus with me, then I will show you that there are times, even if the function is not one-to-one, we still can use the similar technique to find the range. Now, to confirm more about what we learned, for example, let's see what is the y-intercept. What is the y-intercept for this function? Y-intercept f0 equals to, when x equals 0, you have -4 on the top and 6 at the bottom. I get -2 over 3. So the y-intercept is 0, -2 over 3. Now we know that the y-intercept of the function has something to do with the x-intercept of the inverse. Now what I do right now is just to confirm that idea. How to find the x-intercept of a rational function. Well, actually, to find x-intercept, you always set the y equals 0. And then remember, on Tuesday I say that if you have rational function equals to 0, it must be because the numerator equals to 0. And then I solve for x. I get x is -4 over 6, which is -2/3. So my x-intercept here is -2 over 3, 0. I hope you now realize that the y-intercept of the function is the x-intercept of the inverse. And we can actually do the same thing for the x-intercept of the function. X-intercept of the function, that 0 equals to 8x minus 4 over 2x plus 6. I set the function equal to 0. Now multiply by the LCD, it means the numerator has to be 0. Is 1 half. So the x-intercept of the function is 1/2, 0. Later on, you will see, as you can guess, the y-intercept of the inverse function should be 0, 1/2. Okay, the y-intercept of the function should be 0, 1/2. Let's see. F inverse 0 equals to 4 over 8, which is 1/2, right? Okay. Now, suggested homework from here will be number 7 to number 13, 19 to number, you know what, let me make it this way. 19 to number 27, and then number 29 to number 33. The one here do every other odd, and the one here do the odd ones. Okay, now for all of them, show algebraically in 4-step method, the one I showed you earlier today. Okay, what else? maybe on the top of that. No, I guess that's good enough. I guess that's good enough for 2.7. Now your test one, like what I said earlier, oh, am I recording this? Yeah. Your test, I'm sorry, your test three will be 2.6, that's composition of function. Oh, why it is copied there? Yeah. Am I okay? Huh? What happened? Did I copy it there? Give me a second. I want to erase this. Huh? What? Oh, okay. That's good. Yeah, so your test three, which is next Thursday, 2.6 composition function, 2.7 inverse function, and then 3.2 to 3.4 the polynomial. And you can study from my old test three already. Let me see if I have my old test three for you to study from. Files. I'm trying to show you this thing. Do I have test three? My old test three. I have old test two to study. Let me upload test three right now. My spring 19 test three. Give me a second. I give you my old tests for you to study from, but don't do that last minute though. Okay, that's not good for you. Spring 245 test three. Let me post test four also at the same time. I try to be really nice to you. So when I write my test three, actually my test one and test two and test three, I basically copy paste from my spring 19 test, and then I change the number here and there. Okay, but if you don't study, then you are actually wasting your chance. Okay, now your test three and test four from spring 19. Oh, hold on. I think I uploaded the wrong one. Not this one. Test four. Let me do it. That's why I say, to be honest with you, I was kind of upset with the fact that most of you didn't do well in your test. You're supposed to do much better. Yeah, you're supposed to do much better. Okay, so your test three and test four are already there. Mhm. Now let's go back to our discussion. Last time we talked about 4.1, we didn't finish it. Yeah, because I need to do this inverse function thingy. Inverse function part is not too hard. Yeah. If you see my old test, it's mainly about how to find inverse function from a function. Okay, now let me go to 4.1b and continue to what we had last time. So 4.1, we have rational functions. And we have talked about first the domain. Yeah, what is rational function? Rx equals to a polynomial over a polynomial. Now the domain will be all real numbers except the zeros of the denominator. Now then how about the y-intercept? The y-intercept, well, basically you plug in x equals to 0 to the function, right? But you will see that will be 0, comma the constant on the top over the constant at the bottom. Of course, for the constant at the bottom is not equal to 0. Basically, 0 has to be in the domain of the rational function. Now, part C, to find x-intercept, we basically solve for Rx, right? 0, the numerator of the function has to be 0, okay? But x has to be the zeros of px need to be real, need to be real numbers and in the domain. Okay, now let's do one example before I go on with the horizontal asymptote and vertical asymptote, just to remind ourselves what we have done before. Example 1, let a rational function Rx equals to x squared minus 5x plus 6 over x squared minus 4. I will simplify this by first factoring them. X minus 2, x minus 3 over x plus 2, x minus 2. So something canceled here, such that we can say this is equals to x minus 3 over x plus 2. You see, because this guy cancels, right? X minus 2 cancels. Okay, so they are the same for x not equals to 2. Now, if x equals to 2, then this part is 0. When x equals to 2, this is 0, this is 0. Now, 0 over 0 is undefined. Okay, now as long as x not equals to 2, then they are not 0, such that you can cancel them. Okay, that's how then we come up with the simplified version, right? As long as x not equals to 2. If x equals to 2, then the function, rational function, will be undefined. Okay, now then step 1. The first one, what's the domain of the function? The domain of the function, you look at the denominator of the original function. Okay, the domain will be all real number except 2 and negative 2. Part B, how about the y-intercept? You can see that 0 is in the domain, so we can find the y-intercept. That will be 0, comma, negative 6 over 4, negative 3 half. Let's show the word. So R0 equals to 6 over negative 4, which is negative 3 half. How about the x-intercept? I look at the numerator, set it equals to 0. So I get the x equals to 2 or x equals to negative 2. I'm sorry, equals to 3. But you see that negative 2 is not in the domain, so I have to cross it out. Not in domain. Okay, so the x-intercept is 3, 0 only. Now, alternatively, we can find the x-intercept from the simplified version. The numerator has to be 0. X minus 3 equals to 0, x equals to 3. Okay, so the x-intercept is 3, 0. Of course, you still need to check if that 3 is in the domain or not. Okay, I remember last time I taught you how to find the hole. The hole will be, it is the place that is not defined, the canceling. It cancels at x minus 2, right? Okay, so you plug in x equals to 2 into the simplified version. R star x is x minus 3 over x plus 2, right? Now, you input the 2, which is undefined. The one that is undefined in the original function, but defined in the simplified function. Okay, so to identify that the whole, you will see that the 2 is not in the domain of the rational function, but it is in the domain in the simplified function. Okay, now, so you know that the 2 should go to the simplified function. That's how we actually find the location of the whole. So 2 minus 3 over 2 plus 2, that's negative 1, 4. So the coordinate of the whole is 2, negative 1, 4. Okay. Now we will move on further. Now, how about asymptotes? There are two types of asymptotes. The first one, the easy one first. The first one is a vertical asymptote. Now, what is a vertical asymptote? Is the line or lines, the vertical lines, where the graph explodes. I use the word explodes here, to infinity or negative infinity as it gets closer to the vertical lines. The graph, the rational function, the graph of any rational function cannot cross any vertical line, any vertical asymptote. It will go to positive infinity or negative infinity. Okay, let's take a look on the graph. The function we have earlier, I think I will use that. The function we have earlier, y equals to x squared, x squared minus 5x plus 6 all over x squared minus 4. Now, when we say vertical asymptote, it refers to this vertical line here, this vertical line. Okay, and you see that vertical line actually, the line to which, as the graph gets closer, to that x equals to -2, then the graph actually explodes to infinity or negative infinity. So you see, this is the vertical line. This is the vertical line to which, as the graph gets closer from the left-hand side, in this case, it goes to infinity. And as it gets closer to from the right-hand side, it goes to negative infinity in this case. Okay. Now, we actually don't know if we will go to positive or negative infinity in particular. Okay, but we know for sure we'll go to either one of them. And the graph will not cross this vertical asymptote. Okay, the graph will not cross the vertical asymptote. Now, how to find vertical asymptote then? Okay, to find vertical asymptote, we look at the simplified version. In fact, the vertical asymptote is given by a vertical line. So it must be x equals to what? The zeros of the denominator of the simplified version. The real zeros of the denominator of the simplified version. Now, as you can see here, the vertical asymptote is given by this vertical asymptote here is x equals to -2, right? X equals to -2. Now, if you look into the simplified version we have here, you see -2, x equals to -2 is, so looking back into our example 1, our Rx equals to x squared minus 5x plus 6 over x squared minus 4, and we get the simplified version to be x minus 3, x plus 2, right? For x not equals to 2. Okay, now then from there you see the vertical asymptote is x equals to -2. How do you get that? The zero of the denominator of the simplified version. You need to simplify it first, and then you find the zero. If the zero is a real number, then it becomes a vertical asymptote. Okay. Now, how about horizontal asymptote? So that's the first note about asymptotes. The second, horizontal asymptote. Horizontal asymptote. Horizontal asymptote is the horizontal line to which the graph gets closer and closer as x goes to infinity or negative infinity. Now, if we look above here, you will see that our horizontal asymptote on the previous rational function is this line. This is our horizontal asymptote. You will see the horizontal asymptote is y equals to 1. In the previous question. Okay. Now, the graph of rational function may cross horizontal asymptote. Now, for vertical asymptote, you cannot cross it. The graph of any rational function cannot cross any vertical asymptote. Okay, while horizontal asymptote, the graph may cross horizontal asymptote. Now, the thing is, to find horizontal asymptote, you need to memorize such thing, rules for horizontal asymptotes. It actually depends on the degrees of the polynomials n and m. Let's remember this. Degree of the numerator, degree of px, we denote that by n, and m is the degree of the denominator. Okay, now here's the rule. If the degree of the numerator is less than the degree of the denominator, let's say for example, we have x plus 4 over x squared minus 5. You see the degree on the top is only 1, the degree at the bottom is 2. So the degree on the top is 1, degree at the bottom is 2. Okay, now if that's the case, then the horizontal asymptote is given by y equals to 0. Okay, now, if you wonder, but why, Thomas? Why it gets y equals to 0? Well, the reason is this. Because as x goes to infinity, x plus 4 will go to infinity also, right? Now, the thing is, x squared minus 5 will also go to infinity. Both of them goes to infinity, but who goes faster? Who goes to infinity faster? You can imagine that if I drive a car, and I use gear number 1, and you drive another car, gear number 2, and both of us driving to Las Vegas, of course, both of us will arrive. The thing is who arrive faster and what happened to the ratio, right? This guy will go to infinity, this guy will also go to infinity, but we know for sure this guy will go to infinity a lot faster. Okay, so even though the top one goes to infinity, at the same x, the denominator already a very big infinity. So eventually, the ratio becomes 0. Okay, now in calculus for business later on, the way you show that fact will be done algebraically. And the way you will see later on, you don't need to know this now, but it will be as the following. You see, x plus 4 over x squared minus 5. If I divide by x squared on the top and the bottom, x squared over x squared minus 5 over x squared. You see that on the top here, it simplifies to 1 over x. This is 4 over x squared. This is 1 minus 5 over x squared. Now, what happens when x goes to infinity? When x goes to infinity, then 1 over x becomes 0. 4 over x squared is 0. This 1 stays the same. Minus 5 over x squared is 0. So this is basically 0 over 1, which is 0. When you go very far to the right, or actually also when you go very far to the left, you will get the same result. So the value of the function will approach 0. Maybe at some point touching 0. Maybe. It doesn't have to, but could be. Okay. So for us to find the horizontal asymptote, we actually just look at the degrees on the top and the bottom. Second rule. What happens if it's higher? The numerator has the degree more than the degree of the denominator, then we don't have horizontal asymptote. Let's say if I switch that around, x squared minus 5 over x plus 4. You see, the top one goes to infinity a lot faster than the bottom one, and therefore the ratio will be not a constant. Okay, now what happens if they have the same ratio? I mean the same degree. If they have the same degree, then the horizontal asymptote is given by y equals to the leading coefficient over the leading coefficient. Now, in our last example, you saw that, which is our first example for today, remember that Rx equals to x squared minus 5x plus 6 over x squared minus 4. You see that the degree on the top and the degree at the bottom are both 2, right? The degree of both of them quadratic. So the horizontal asymptote will be y equals to the leading coefficient on the top over the leading coefficient at the bottom. Okay, now don't forget horizontal asymptote is a horizontal line. So when you write the quotient, when you write the horizontal asymptote, the equation, it has to be a horizontal line. Now let's take a look on some problem in 4.1. Now I'm not going into graphing yet. On Tuesday next week, then I will teach you 4.2 how to graph this, how to graph a rational function. But for now, we already have enough foundation to do this problem. Let's say, for example, on 4.1 number 12, we have the rational function fx equals to 3 minus 7x over 3 plus 2x. Now let me write them in a descending order. Negative 7x plus 3 over 2x plus 3. Let's answer whatever we can answer now. First one, what is the domain? The domain 2x plus 3 cannot be 0, right? Okay, so 2x cannot be negative 3, x cannot be negative 3 halves. So the domain will be all real numbers except negative 3 halves. Part B, how about the y-intercept? To find the y-intercept, as usual, we plug in x equals to 0. When I plug in x equals to 0, I get on the top I get 3, the bottom I get 3. Those are the constant of the numerator and denominator. So f0 is 1. The y-intercept therefore is 0, 1. Part C, how about the x-intercept? It means I need to set the function equals to 0, right? Negative 7x plus 3 over 2x plus 3. Oh yeah, if it is a rational function equals to 0, then the numerator has to be 0. Is that right? So 7x equals to 3, x equals to 3 over 7. So x-intercept is 3 over 7, comma 0. Now part D, how about the vertical asymptote? Now that function already in simplified form, nothing more to cancel. So the vertical asymptote will be x equals to a vertical line, the 0 of the denominator, negative 3/2, happens to be the same to this. Actually, vertical asymptote is any, must be part of the number you exclude there. But there's a chance that you have some number here, but it does not become a vertical asymptote. It's possible. If it doesn't become vertical asymptote, then it becomes a whole. Okay? Yeah, but basically, the vertical asymptote will be x equals to the zeros of the denominator. Okay, the zeros of the denominator of the simplified version. Now, this is already simplified, nothing to cancel, so we just leave it like that. Part E, how about the horizontal asymptote? Notice that they have the same degree. The degree of the top is 1, the degree of the bottom also equals to 1. Right? So the horizontal asymptote y equals to the leading coefficient over leading coefficient. So y equals to negative 7/2 or negative 3.5. Okay, the leading coefficient we were talking about is this leading coefficient and this leading coefficient. Okay, now I would like to do more problems. Let's say number 36. Number 36 from this 4.1. Let fx equals to 6x squared minus 11x plus 3 over 6x squared minus 7x minus 3. You need to know how to factor this though. Okay, I don't forgive you if you don't know how to factor. You have to know how to factor at this point. Let's factor the top. I think that will be 3x 3 minus 1. This is 2x minus 3. So there will be negative 9x minus 2. That's negative 11x. On the denominator, that would be 3x and x. I think that will be plus 3 here. Oh, 6x. Nope. It should be 2x plus 3. So that's positive 9 minus 2. That's positive 7. Oh, no. I want negative 7. So let me change the sign. This becomes plus here. And this becomes minus. We can simplify this. So the simplified version, the f star x is 2x minus 3 cancel. I get 3x minus 1 over 3x plus 1. as long as x is not treehouse. It will be undefined when x equals to treehouse. Okay, then part A was the domain. Once you factor it, so you really need to know how to do factoring though. But once you can factor it, then finding the everything basically super fast. The domain, all real number except -1/3 and +3/2. Right? I need to avoid this to be 0 and this to be 0. Okay. And then part B, how about the y-intercept? Y-intercept will be, what is F0? Now in my test later on, that's basically in test 4. What is F0? You see, oh, it's a constant over the constant. That's -1. So the y-intercept is 0, -1. How about the x-intercept? You set the function to be 0 and only look at the numerator. So 1 equals to 3x, x equals to 1/3. Yeah, make sure that that 1/3 is in the domain though. Okay. Part D, how about the whole? How about the whole? You will put this 3/2, which is the 0 of the cancel factor, into the simplified form. Okay, so f star 3/2 equals to 3 times 3/2 minus 1 over 3 times 3/2 plus 1. That's 9/2 minus 1. That's 9/2 plus 1. Oh, multiply the top and the bottom by 2. Give me 9 minus 2 over 9 plus 2. That's 7/11. Oh, I like that number. So the whole is located at 3/2, 7/11. Part E, how about the vertical asymptote? Vertical asymptote, look at the simplified form. X equals to the 0 of the denominator. So 3x plus 1 equals to 0. 3x equals to -1. X equals to -1/3. That's the equation of the vertical asymptote. How about the horizontal asymptote? They have the same degree, both of them degree of 2. Okay, so horizontal asymptote is given by y equals to leading coefficient over leading coefficient, which simplifies to be y equals to 1. So your suggested homework will be from 4.1 will be from number 7 to number 15, so number 9 to number 15, number 21 to number 35. And for all of these questions, what I want you to do is to find the domain, y-intercept, x-intercept, vertical asymptote, horizontal asymptote. That's all you need to do. Okay, see you then next Tuesday.